Hi everyone, welcome back to Lulumath. This video is on negative exponents. And in order to fully understand this video, you'll need to know how to divide monomials, as well as you need to have an understanding of zero exponents. Both of those videos are available at lulumath.com or the Lulumath YouTube channel if you need a refresher before you watch this video. So we need to do some division here. So here we've got 2 to the power of 5 divided by 2 to the power of 3. And if you were to do 2 to the power of 5, you would get 2 times 2 times 2 times 2 times 2. And 2 to the power of 3 is 2 times 2 times 2. So here we've got a bunch of 2's that cancel out, and we've got 2 2's being multiplied together that are left over. Or we could just say simply that our answer is 4. We could also just simply evaluate 2 to the power of 5 and say that that's 32, evaluate 2 to the power of 3 and say that that's 8, and then 32 divided by 8 is equal to this 4 that we get right here. But just a reminder that when we divide, we would subtract our exponents. So 5 minus 3 is 2, and that's how we get this exponent of 2 up here. So let's go ahead and try this with our next example. 2 to the power of 4 means 2 multiplied by itself 4 times. 2 to the power of 3 means 2 multiplied by itself 3 times. And we have 2's that cancel out. 3 sets of 2's cancel out. And we have one single 2 left over. Now again, this should work for us because our exponents are 4 and 3, and 4 minus 3 is equal to 1, and that's where we get this 1 left over here. And 2 to the power of 1 is simply 2. Now, we could also say that 2 to the power of 4 is equal to 16, and 2 to the power of 3 is equal to 8, and 16 divided by 8 gives us this 2 that we got here. Now, in our next one, we've got 2 to the power of 3 divided by 2 to the power of 3, or 2 to the power of 3 divided by itself. So remember, 2 to the power of 3 means 2 times 2 times 2, and we will do that in the denominator as well. And all 3 of our 2's in the numerator and the denominator cancel each other out, which means that we have no 2's left over. So we've got 2 to the power of 0. Again, we should also know that it's 2 to the power of 0 because 3 minus 3 is equal to 0. But what is this as a single number? Well, 2 divided by 2 is 1. 2 divided by 2 is also 1. 2 divided by 2 is also 1. 1 times 1 times 1 is 1. Also, 2 to the power of 3 divided by 2 to the power of 3 is a number divided by itself, and we should get 1. Lastly, if you're not fully convinced, 2 to the power of 3 is equal to 8, both in the numerator and the denominator, and 8 divided by 8 is equal to 1. Now here's where things get a little bit trickier. Here in our numerator, we have 2 to the power of 2, which means 2 times 2. And in our denominator, we have 2 to the power of 3, again, which means that we have 2 times 2 times 2. Now, this 2 will cancel out with this 2, and then this 2 in the numerator will cancel out with this 2. And remember, when we say they cancel out, we end up getting 1's. So here in the numerator, I have a 1 left over. 1 times 1 is 1. But in the denominator, I still have this 2 left over. So we can say that this is 1 over 2 here. But if I were to subtract my exponents like we did in these examples up here, I would have 2 minus 3, which is equal to negative 1. So this tells me that my exponent would be 2 to the power of negative 1, and I end up getting a fraction of 1 over 2. Now this 2 right here technically has a 1 as an exponent, a positive 1, when it's put in the denominator. Now look here as well. 2 to the power of 2 is 4, and 2 to the power of 3 is 8. And when I divide 4 by 8, I end up getting this 1/2 that I have right here. So this is interesting. What is this telling us about negative exponents? Let's try another example. So in my numerator here, I have 2, or 2 to the power of 1. And so that means that I have a single 2 in the numerator. On the bottom in my denominator, I have 2 to the power of 3, which is 2 times 2 times 2. And here we can say this 2 and this 2 will cancel out to give us 1. We talked about this in the zero exponents video, but just a reminder, it cancels to get 1. We also talked about it in the dividing monomials video as well. So I'm left over with a 1 in the numerator, and then I have 2 times 2 in the denominator, which is 2 to the power of 2. So I simply have 1 over 4 as my answer here. Well, when I subtract my exponents, 1 minus 3 is equal to negative 2. So this is telling me that 2 to the power of negative 2 is the same thing as 1 over 2 to the power of positive 2. So what is this negative exponent telling me? Well, we know 2 to the power of negative 1 is 1 over 2 to the power of 1 as we figured out here. 2 to the power of negative 2 is 1 over 2 to the power of positive 2. So if we extend this pattern, maybe we can say 2 to the power of negative 3 is 1 over 2 to the power of positive 3. Let's see if this is true. So I will try 2 to the power of 2 divided by 2 to the power of 5. And I know 2 to the power of 2 means 2 times 2. And I know 2 to the power of 5 means 2 multiplied by itself 5 times. And we can say this 2 will cancel with this 2 will cancel with this 2, and they cancel to give us 1. So I have a 1 left over in the numerator, and 3 2's being multiplied together in the denominator means I've got 2 to the power of 3 left over down there. And if I were to subtract my exponents here, 2 minus 5 is negative 3. So this is 2 to the power of negative 3. Therefore, we can say that 2 to the power of negative 3 is the same thing as 1 over 2 to the power of 3. By extension, we can say that 2 to the power of negative x is equal to 1 over 2 to the power of positive x. All right, in our next example, we're asked to divide again, and we have x to the power of 3 divided by x to the power of 5. And when we divide, we subtract our exponents, so 3 minus 5 would give us negative 2. So we'll get x to the power of negative 2. Now, what does that x to the power of negative 2 mean? It just simply means 1 over x to the power of positive 2. Now, let's confirm that this is really true. So x to the power of 3 simply means x multiplied by itself 3 times. And x to the power of 5 simply means x multiplied by itself 5 times. And so we know that this x and this x cancel out to give us 1. X and x cancel out to give us 1. X and x cancel out to give us 1. So we end up getting 1 in the numerator and 2x is being multiplied together in the denominator. So we get 1 over x squared. Okay. In our next example that we have here, we will want to divide the 15 by the 3 and we get 5. And then here we want to subtract our exponents. So 2 minus 6 is negative 4. So we end up getting a to the power of negative 4. Now, how do we rewrite this so that we don't have any negative exponents? Well, it's just simply going to be this 5 is technically 5 over 1, and that 5 stays in the numerator because it does not have the negative exponent on it. So we keep it where it was. But this a to the power of negative 4 needs to move where it wasn't before. So it was originally in the numerator. We're going to move it to the denominator, and then that negative 4 exponent will turn into a positive 4 exponent. Now, let's talk about why this is true again. So in my numerator, I still have a 15, and in my denominator, I have a 3. And a to the power of 2 is a times a. And a to the power of 6 is a multiplied by itself 6 times. Now, looking at this here, 15 and 3 are both divisible by 3, and 15 divided by 3 is 5. 3 divided by 3 is 1. This a and this a cancel out to give us 1. A and a cancel out to give us 1. So looking at what we have left over here, we have a 5 left over in the numerator. 5 times 1, which is just 5. In my denominator, there's 1 times a to the power of 4. And that's how we get this answer here. Okay, in our last example, we've got a lot of stuff going on here. We've got 12a to the power of 3b squared c squared, all divided by 16a to the power of 3 b c to the power of 4. So let's talk about this. For starters, 12 and 16 are not evenly divisible. So if I were to reduce these two coefficients, 12 and 16 are both divisible by 4. So 12 divided by 4 is 3, and 16 divided by 4 is 4. To look at this a to the power of 3 divided by a to the power of 3, when I subtract these exponents, I would get 3 minus 3, which is 0. So I would get a to the power of 0. Then for this next one, b to the power of 2 divided by b to the power of an invisible 1, 2 minus 1 is 1. So I would get b to the power of 1. And here, c to the power of 2 divided by c to the power of 4, 2 minus 4 is equal to negative 2. So I'd get c to the power of negative 2. Well, let's talk about this a little bit further. So in my numerator, I have 12. And then I have a to the power of 3 means a times a times a. B to the power of 2 means b times b. And c to the power of 2 means c times c. In my denominator here, I have 16. A to the power of 3 means a times a times a. B just simply means b. And c to the power of 4 means c times c times c times c. Now again, this 12 and this 16 are both divisible by 4. So 12 divided by 4 is 3. 16 divided by 4 is 4. So I end up getting 3 in my numerator and 4 in my denominator. Now here, this a and this a cancel out. A divided by a is 1. A divided by a is 1 again. So I end up getting a lot of 1s. Well, anything times 1 is itself. So I don't have to put anything down. Also, a to the power of 0 means that there are no a's here left over at all. So we won't write any a's at all. Now here, this b cancels out with this b, and we have a b to the power of 1 left over. And then here, this c will cancel with this c will cancel with this c to get 1. And then I've got two c's multiplied together left over, or c to the power of 2. Now, how is this answer here related to this answer here? Well, if you see, we have our 3/4 here and we have our 3/4 here. There are no a's left over at all, so a to the power of 0 is 1. So 3/4 times 1 is simply just 3/4. We've got b to the power of 1 here. And since it's a positive exponent, we keep it where it is. And then we've got c to the power of negative 2. And because it's a negative exponent, we put it where it was not. So we've got c to the power of 2 in the denominator. So essentially, a negative exponent is just telling us to do the reciprocal. So again, an example would be x to the power of negative 2. Well, this is x to the power of negative 2 over 1. So I would do 1 over x to the power of 2. Another example would be 6a to the power of negative 3 means I would keep the 6 where it is, and then I would put the a to the power of negative 3. I would do the reciprocal of it, so I'd get 6a to the power of 3. And our last example that we have here would be if we have 1 over 5x to the power of negative 4. So this 5 here would stay in the denominator because it's a positive exponent. It has an invisible exponent of positive 1. And this x to the power of negative 4 would actually do the reciprocal of it, and it would go up into the numerator. Now, there is going to be another video on negative exponents with more details on what to do with negative exponents that are in the denominator. But for right now, this is the information that we need to know for a basic understanding of negative exponents. If you have any questions, please let me know in the comments below or at lulumath.com, where you can also find blank or completed notes for this video. If you found this to be useful, please make sure to subscribe and share with others. Thank you, and we'll catch you next time. Bye.